Go ahead. Go ahead.
Still be almost. Yes.
You should be able to.
Good. All right. Good evening. Welcome to the National Academy of Sciences. I'm Greg Sims, the chief Executive Officer of the National Research Council here at the Academies and Chief Operating Officer of the National Academy of Sciences. We're so pleased to have you here today for this evening for one of the signature events of Space Science Week 2025, a week that brings together leaders from across the Space Studies Board, spacefaring nations, and interested public participants. It's a gathering that celebrates scientific achievement, fosters interdisciplinary dialogue, and deepens the international cooperation that fuels our progress in space and earth science. Tonight's keynote event is a reflection of everything this week is about: creativity, curiosity, and the power of collaboration across boundaries. We are honored to welcome two extraordinary individuals whose partnership spans 2 decades and 2 worlds, science and art. Together, they've created a remarkable project titled The Warp Side of Our Universe, an Odyssey Through Black Holes, Wormholes, Time Travel, and Gravitational Waves. Dr. Kip Thorne is a Nobel Prize-winning physicist, a longtime Caltech professor, and a member of the National Academy of Sciences. He's a pioneering figure in gravitational physics and space-time theory. And yes, he's also the scientific advisor behind Interstellar, where he helped make black holes Hollywood stars. Lia Halloran is an award-winning artist and professor who chairs the Department of Art at Chapman University. Her work translates complex astrophysical ideas into vibrant, emotionally resonant visual art, reminding us that science isn't just about knowledge, but about wonder. Together, Kip and Lia show us how art and science are not opposites, but partners, each offering new ways of seeing and understanding the universe. Moderating tonight's discussion is Taras W. Matla, Director of the University of Maryland Art Gallery. We're grateful to have him guide this dialogue between theory and expression, between cosmic physics and creative imagination. And after the talk, I encourage you to visit the exhibition of Kip and Lia's work in the upstairs gallery. And that's organized by the cultural programs of the National Academy of Sciences. And you'll find it just outside the auditorium via the main staircase. And now it's my great pleasure to welcome to the stage Dr. Kip Thorne, Lia Halloran, and Taras Matla.
Good evening. Are we on?
Well, thank you for your kind introduction, and it's a great pleasure to be with you today to talk about our wonderful collaboration, the book that it produced, and especially Lia's paintings, which is what you will see up there at the end of this presentation. Many of them are on exhibit here in the National Academy of Sciences, not all, unfortunately, not all 605 of them, a smaller selection.
And we want to say a special thanks to JD Talixek and Alana Quinn for the kind invitation to bring the artwork from the book here and the invitation for this opportunity to do this talk with our friend Taras. And we're excited to tell you about the book. But first, before our discussion, we're going to read from you the prologue of our book, accompanied by paintings that will explain a little bit about what the book is about.
Our universe is varied and vast. Galaxies, planets, stars, and moons, quasars, pulsars, and magnetars, all made from atoms and molecules just like you and me, and all that we see and touch and see. Our universe is also endowed with a marvelous shadowy side that is warped, phenomena forged from warped space-time. Witness the ravenous fat black hole that Lia here depicts ingesting her wife, Felicia.
Although this warp side is entwined in the weft of our matter-filled universe, its stars, its planets and nebula, its galaxies and its comets, we humans never saw it until just recently. Why did we never see? Warp space-time cannot produce light or other signals that yesterday's technology was able to perceive. So now, how has that changed?
A very long time ago, a billion years in the past, while here on Earth, multicelled life arose and spread around the globe. In a galaxy far, far away, two spinning black holes danced around one another, rippling the fabric of space and time. The ripples, we call them gravity waves, sucked energy from the hole's orbit, so the holes spiraled inward, eclipsing each other toward a climactic collision. The holes at half of light speed catastrophically collided and merged in a brief cataclysmic storm of writhing and twisting space-time that brought the waves to crescendo.
The climaxing gravity waves from this catastrophic collision surged out of their birthing galaxy and into interstellar space. Spreading across our universe for nearly 1 billion years, they stretched and they squeezed all that they met, stars and planets and nebula, in patterns that encoded a portrait of their birth, colliding holes and space-time storm. Then 50,000 years ago, when humans shared Earth with Neanderthals, the spreading and weakening gravity waves sailed into our spiral-armed Milky Way, our galaxy, our home.
On September 14th of 2015, near the Antarctic peninsular tip, the waves flying upward plunged into the Earth through air and then oceans, then rock. Whispering up through Earth's bowels unscathed and emerging just north of New Orleans, the gravity waves came face to face with a complex and huge L-shaped invention designed and built to perceive them. LIGO, the Laser Interferometer Gravity Wave Observatory. Flowing through LIGO, the gravity waves stretched and then squeezed microscopically two very long beams of bouncing light that extracted the portraits the waves had encoded, colliding holes and space-time storm.
This tiny shutter in LIGO was momentous for the whole human race, our very first moment of contact with the warp side of our universe. The warp side of our universe is home to many beasts, beasts that are forged from warp space and time, beasts that may well include black holes and wormholes, time machines and cosmic strings, gravity waves and singularities, our universe's Big Bang birth, and many other beasts, wondrous, weird, and wild.
For decades, I, a beast, materially composed, have been consumed by quests to fully comprehend this warp side of our universe. How? Through tricks of mathematics and computer simulations, probing Albert Einstein's relativity equations. And in a 1,000-person fleet of scientists and engineers, we've pursued a quest to invent, construct, and utilize our behemoth LIGO for humans' first contact with the warp side of our universe.
Big questions have driven these warp side quests, some that I'm sure you've asked yourself, and some likely you have not. How did our universe begin? Can anything travel backwards in time? Can advanced civilizations build wormholes for fast interstellar travel? How does warped space-time behave when wildly, frenziedly writhing like the open sea in a storm? How does the warp side of our universe impact the material side, the side that we humans see and feel?
In this artistic, poetic book that will undulate in your hands, Lia and I use paintings and verse to shed some glimmers of light on all of these big questions. But first, we shall pause to explore the quintessential example of a beast who inhabits the site that is warped, the black hole. Now, this is how our prologue ends. A black hole has a rich variety of features, all made from warped space-time, nothing made from matter. Likely a far richer set of properties than you have ever heard of or imagined before. The first chapter of our book introduces these features one by one and then summarizes them in the following way.
What is Felicia? She's the sum of all her parts. Her face, her silken hair, her arms and breasts, her hands and legs and feet, her heart, her brain, her precious personality. And what is a black hole? It's the sum of all its parts. It's space that is warped, the funnel of bulk being seas, its vortices of whirling space, its tendencies that stretch and squeeze, its slowing time and down cascading time, its horizon and its singularities, all made from warped space-time.
All right, thank you very much. We're now would like to invite Taras to join us on stage.
My water.
Good evening, everybody.
Don't share everything else. So.
Before I begin to interrogate these two individuals, I too want to express my gratitude and thanks to the National Academy of Sciences for hosting such a wonderful event, and an enthusiastic one with a lot of people who represent so many diverse fields, not just in the sciences, but in the arts. And it's wonderful to see us in many ways kind of coming back together, because we were at one point as disciplines connected. There was a time centuries ago where we didn't distinguish between, all the different fields that we do now. And so it's kind of nice that in some ways history has given birth to all these fields, and we've all come back as brothers and sisters in pursuit of truth and what the universe is all about. So with those profound words, I'm going to dive in and ask the first question. How did the idea of the warped side of our universe come about? This is an open-ended question to either Kip or Lia. Who wants to start?
Yes, I'll begin. I always like to say that our collaboration started before Kip knew we were collaborating.
I'm a lot older than she is. Twice her age.
So I am an artist who has always been inspired and excited by nature. When I was in graduate school, it was the first time that I actually thought that science could be the subject matter of my work. And my mother had gifted me this book called Black Holes and Time Warps, Einstein's Outrageous Legacy, which was Kip's book. And there was something in that book that went beyond my studies, and it made me actually feel like it was an invitation to the experience of the universe. And there was a particular section in there that inspired my kind of anchor painting in my MFA show at Yale University. And years later, it was like 5 or 6 years later, both Kip and I were at a cocktail party in Pasadena for a mutual friend of ours. And I overheard someone say something, 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 Kip Thorne. And I was like, where's Kip Thorne? And I ran up to him and completely gushed, no chill whatsoever.
And she urged me to come to her studio.
I feel like urge is that's kind. I was like,
Yeah,
beg. I was like,
I would call it urge.
yes.
But when I went to her studio and I was blown away. Her paintings were so evocative, so beautiful, so tied to science as well, many of them. But they just emoted to me the feelings that were associated with these scientific concepts. And
And at that time, Kip said, so there's a young filmmaker who's interested in making a film about my science, but I need someone who understands the science to actually depict it. Would you be interested in making drawings so I can visually kind of present them? And I was like, of
so
course.
she opened up a little book that had sheets of drawing paper on it, and she sketched out a marvelous drawing just then and there, a pencil drawing of black holes and wormholes emerging from a two-dimensional model of our universe. And I looked at it and said, this is absolutely ideal. I'm meeting with this young filmmaker. His name is Steven Spielberg. And
Anybody heard of this young film? We don't know how he's doing in his career, but we have.
anyway,
I heard
so-
pretty good. I heard pretty good.
So I showed it to Stephen as a starting point for discussing what would become the movie Interstellar. And it was a great starting point. And then after several years working with Stephen and with Jonathan Nolan as the screenwriter on the project, Stephen, who carries along more movies in its early creative phase than he can possibly do, he chose to do Lincoln. And he said, I know that Christopher Nolan is waiting in the wings, possibly interested in this, and he's the right director for you. And he was the right director for us. When Christopher Nolan took over the film after 2.5 years of waiting, and we were on tenterhooks for 2.5 years, again, I showed him this drawing, and it was the great starting point for him as well on our collaboration on Interstellar.
Yeah, and that was, it was an introduction for us to become friends. And a couple years later, Kip had an introduction to do a article in Playboy, because that's how all great collaborations start, right? Who among us has not done a Playboy?
So, well, the issue is that my editor on Black Holes and Time Warps, which was with Norton, W.W. Norton and Company Publishers, she had moved to Playboy as their literary editor in the era when Playboy was trying to distinguish itself from other, quote, gentlemen's magazines by having interviews with eminent people and articles by eminent scientists and people in world culture.
This is what Kip told himself to agree to.
Yeah. And perhaps Mr. Hefner may have misconstrued the subject matter.
So well, I don't know to what extent he was involved at that stage, but they did look at. I said I would do it if Lia could do the paintings for the article, and the art editor looked at her paintings and enthusiastically brought her onto the project. So we had a contract for this article, and when we submitted it, Hugh Hefner personally looked at the article and the paintings and said, I can't publish this because the women in Lia's paintings are not up to the feminine standards of Playboy.
So I hadn't properly objectified the women in the article, which I hold as a big badge of honor. To be personally rejected by Hugh Hefner.
So we thank Hugh Hefner for rejecting this article because that was the start of this wonderful collaboration. We decided we would turn it into a book. And so we're not done. This
Yeah.
is
Oh, yeah. I'm gonna let you go.
Yeah.
and so we started turning it into a book, and it sort of grew organically. And but it was prose and her paintings. But then Lia had a friend lay out the book on the page when we had about 20 pages of prose and paintings. And that friend laid out some of my prose in what looked like stanzas of verse alongside some of her paintings. And not the whole thing that way, but enough of that way that I looked at this and I had an epiphany. I realized suddenly that perhaps I could turn everything into verse, and we could explore the possibility of conveying to non-scientists the essence of the science we were talking about, the warp side of the universe, through tightly coupled verse and paintings. And so it became an experiment in that direction that the two of us just had great fun.
I would also just say that this was a moment where we started actively talking about trying to create something that hadn't existed before, right? That we wanted to create a wide invitation to a broad audience, that someone who's an artist would say, that's my book, or someone who's a poet would feel like that was their book, and that it was actually an intimate invitation. So,
Scientists too.
and, that's right. Sorry, scientists too. You're all invited. But you'll also notice that there's one space traveler, and the one space traveler in that book is my wife, Felicia. So there was like kind of equal skin in the game of intimacy. For Kip hadn't written poetry except for some poems to his wife, Carol Lee, who's here. And that my wife, Felicia,
Love
would
poems
also.
to his wife.
I mean, I think this is really a love letter to black holes and gravity, this book.
Great. The next question deals kind of more with, Lia, what are your impressions of Kip's writing? Because, you know, a lot of times his writing is can be technical, you know, and it's, I'm not a scientist, I'm not a theoretical physicist, but, you know, it's can be confusing for artists if you're not versed in the lexicon. So in your initial exposure to reading this material and trying to kind of get, you know, a grasp on the concepts, you know, what were your impressions?
Well, I would say it was kind of the opposite. I had started off when I was an undergrad thinking that I would double major in astrophysics. I always knew I wanted to be an artist, but I just loved the challenge of thinking about science and especially astronomy. But it's actually, Kip spends so much time crafting his words that the book that was gifted to me, it was this it felt like an open invitation to really think about how one's body could be embodied into these concepts. It went beyond a concept into, you know, how it could feel like very personal. So I found that his writing that I was first introduced to, it actually inspired the way that I even thought about science. I mean, of course, his book, Gravity, we all use it as a doorstop. There's that book. Then the other books.
Yeah.
Laughing because you can.
Yeah. As you were writing your material for the book, Kip, were there any things that maybe when you were looking at Lia's work in particular that you thought, maybe I should adjust the text?
It really was a process of going back and forth between us. The paintings and the verse grew organically. We went, most every painting in that book, I think you went through 5 or 6 drafts of, and more.
So, you know, when Kip said upstairs, there's 31 paintings from the book. In the book itself, there's about 180 paintings, but over the 13 years, I made 660 paintings because the process of iteration was so fun and organic. And just like Kip's saying, it really was like I'd make a painting and Kip would make drawings next to me, really making
But
these.
then I would see her paintings and I would think, I want to change the verse a little bit in this way or that way that fits a little bit better with the painting as it evolved. And so it was, it really was a true collaboration and feedback between the verse and the paintings.
Was the collaboration always kind of in person, or was it sometimes through email, or sometimes just get on the phone and be like, I don't know, Kip, you know, this is.
Well, it was in person and on Zoom.
And on Zoom, of course, yeah.
And, you know.
Most of it was in person. I think that it's hard to, you know, it sounds strange to say, like you can hold up this, you know, this book, it looks very substantial, but we never actually were setting out to make a book. We actually called it our little book for so many years that our publishing agent said, you have to stop calling it the little book. Because it just kept organically growing out of these conversations. So, you know, after meeting, something he said might inspire me to make like he's saying many more paintings. And then there's a whole chapter about the discovery of LIGO. And I had to let Kip know we had to put in that there was a Nobel Prize that was won. That was not part of the, so the images created the words and the words created the images.
Were there any kind of surprising moments or maybe kind of points of tension, you know, during this collaboration? People always want to know the juicy stuff here. That doesn't make it in the book. Right?
I think there was one, I think, where, well, we should begin. You chose to make the book all in blue, in shades of blue, which is really amazing. Why did you do that? Can you explain that?
14 years, you're asking me this question.
I'm feeding you a question. You have an audience.
Well, it was inspired by your writing. I loved that. First of all, you can see the paintings are very moderately sized. If you look at my website, I make very large work. And this was an opportunity for me to do something that was like elegant and simple. And I thought that just like what poetry aims to do, take complex ideas and distill them into like beauty and elegance, it'd be a lot harder to do that with something that was very simple. And so I wanted to pair the way that Kip was writing in this way that felt also just like it just sort of organically, perfectly appeared. So.
But then there arose the issue that in the science we were talking about, there were several places where there was a duality between two different concepts. Tidal forces, like the tidal forces that the moon exerts on the Earth to raise the Earth's tides on the Earth's oceans. They have two components. There's a stretching to and toward and away from the moon, and a squeezing transverse. So their stretching tendencies, the concept of a tendex was invented by a student that I was collaborating with, David Nichols, who's now at the University of Virginia. Invented the phrase, but it comes out of the mathematics where you see in the so-called Riemann curvature tensor, mathematically, there is a stretching and there's a squeezing. Two that they pair together. And then there are vortices of twisting space, but there's right-handed vortices where if you think of taking a wet towel and you wring water out of the towel, if your left hand sees your right hand going clockwise, then your right hand will see your left hand going clockwise. So there are clockwise vortices of twisting space, and there are counterclockwise vortices of twisting space. And there are vortex lines that guide these vortices, but there are right-handed vortex lines and left-handed vortex lines. So I said to Lia, we have to have two colors. We've got to have some other color that represents this duality. There's blue that represents, say, clockwise, and then something else represents counterclockwise. I met a little bit of resistance.
Took like a year to convince me, but I would say we were really trying to make something that was not didactic. That was a huge point of our book, right? That you just kind of felt that you could be transported by the book. So this was such a perfect solution that you visually would look, the blue is actually like this slightly green blue, and what you read as red is actually an orange red, and you just visually look at it and you would like, similar to the kind of poetic match of the blue, you would kind of understand that it was the opposite.
So that was her solution.
Yeah, I think in early ones there was like words, and we were trying to avoid
that's
having
right,
any kind of language. in there.
But then you made the choice to bring in this sort of orange-red color after we tried other things, like I think we had dashed lines and solid lines, but that never really conveyed it. But that was I think your one concession to being didactic, that this duality you conceded on.
But we've always had so much fun working together that we never came to a part that we didn't agree.
Oh.
You know, it was always like the fun of going back and forth. I also like to think of the book as like a moment in time. Like if the publisher hadn't taken the final draft away from us, it would just be like another 60 or 100 pages. We've worked on a new section that's called vacuum fluctuation.
In fact, we just did something at the Kennedy Center last night where the first half was from our book, but the second half is entirely new material that would be in the book if we had not shut things off when we did.
Lia, in your work, a lot of it involves, focusing on making the invisible seen, And so as an artist, what is your creative process to trying to kind of, almost like a magician, like pull a rabbit out of a hat, that was once empty and now has, an object in it?
So a lot of my work, I would say the subject matter is like time, perception, thinking about things, or scale, thinking about things that are very hard to pin down. And I would say, like, in this book, it gave me an opportunity to try to maybe visualize things that were unseen, like you're talking about. One of my favorite moments was Kip described these vacuum fluctuations in one of our first conversations. And I was like, having a hard time understanding, like, well, what do they look like? And he's like, well, I don't know. Once you paint it, then I'll be able to see it, And that, that gave me like a great
Yeah.
freedom. And
It was a sort of a half joke, but it turned into some reality. She painted something that really resembles sort of probability distributions for these vacuum fluctuations.
And actually, that's a good way to put it. It's like, I'm not trying to exactly represent a thing when I'm representing invisible forces, but maybe the feeling of it, or what the approximation of those things are. And I think I bring that to my other larger studio practice.
Yeah, I mean, it's interesting that you mentioned the talk yesterday at the Kennedy Center, because you did go into the second portion, which dealt with quantum fluctuations, and that's definitely of great interest, to theoretical physicists, among other disciplines. And Lia, we were talking earlier today, that I always, as an art historian, I like to make these comparisons. And after yesterday's talk, went out for a drink. Kip is always very thorough. He's like, I'm going to go to sleep. We went out for a drink. And then I went home and I started thinking about what's a great kind of, art historical moment that we can maybe kind of tie into the idea of quantum fluctuations. And I was struck by the work of John Cage and his monumental work of 4 minutes and 33 seconds, where for those who don't know the composition, he created it in 1952. It's famously performed by another wonderful artist, David Tudor. And it's basically, it can be performed on any instrument, but basically the musician comes out, let's say to a piano, sits behind the piano, and stays basically motionless for 4 minutes and 33 seconds. And the interesting about it is that it's not about the sound that comes out of the piano, but it's more of an emphasis on the ambient sound that's created around the work. And so I thought it was such a wonderful comparison between, silence in this work and, the mystifying, ideas of vacuum, and trying to create perfect ideals, and the fact that perfect ideals potentially don't exist. Perhaps you can kind of elaborate on that.
Yeah, well, I describe vacuum fluctuations in the verse as you remove everything you can possibly remove from a box, but you can't remove everything. Because of the uncertainties in quantum mechanics, you're always left with fluctuations of everything that ever could reside inside the box. Tiny fluctuations of these things fluctuating in and out of existence. Electrons, virtual protons, virtual positrons, virtual Lias, virtual cats and cows and clocks and whatever it is. But I think, so the missing part that's not in this book, which we talked about last night and will be in some future publication, is the central role of these vacuum fluctuations in cosmology. They graciously swallow energy from expanding or twisting space, giving rise to what's called Hawking radiation of black holes, giving rise to, in the theory of inflation, to everything that exists in our universe, giving the possibility to hold wormholes open. Very likely vacuum fluctuations destroying any time machine that an advanced civilization creates at the very moment the time machine is turned on, and vacuum fluctuations as the central key to what is now called quantum precision measurement or quantum sensing, which has grown out of university-based research, out of LIGO, in fact, but is now a major effort in private companies around the world. So these vacuum fluctuations are central to the universe. You can't separate them from warped space-time. They're always there, and warped space-time utilizes them. And you will not be able to separate them from 21st century technology because they are really central to the future of very high technology. So that was the message which we do in paintings and verse.
Like what you said about the this kind of ambient performance. I think even in some of the imagery of the black holes, that's a big component of our book in and of itself, that we're sort of like depicting the visual, depicting an experience of one that we will never actually have, but can we learn something about it through these approximations? So whether it's the ambient performance or the, it's like being around it, it's sort of like you circle around it and you know more about it by still never really experiencing it.
Can you explain a little bit about what role images play in your own understanding of the universe?
Yeah, so the laws of physics, so far as we as humans can tell, are written in the language of mathematics. The mathematics is capable of capturing how the universe behaves through a set of when you understand them deeply, are a set of fundamentally simple physical laws that control how the universe was born, how it evolved, and that we use in order to conceive and develop modern technology. But the laws of physics, when it comes down to doing real calculations to figure out how things ought to behave in the universe or how you ought to design some sort of an instrument, it's very slow working to manipulate the laws of physics and figure things out. And so if you're a physicist or an engineer, you need some other tools to be able to guess how things go in order to decide what calculations to do. Guess how things go in order to decide how to do a first version of a design for an instrument. But then you do the mathematics afterwards in the direction that your guess suggested, and you see whether or not that made sense. And if that says it made sense, then you actually build a prototype for your instrument. But the guess, the leap that guides you in your research, whether you're an experimenter or a theorist, an engineer or a physicist, the leap that guides you is physical intuition. And for most of us, certainly for me, physical intuition is built on mental pictures. And that was true of Stephen Hawking, who was my closest personal friend. It's not true of everybody. Subramanian Chandrasekhar, a wonderful, brilliant astrophysicist at the University of Chicago and also a close personal friend, he never thought in terms of pictures. He looked at the mathematics and he manipulated the mathematics in order to make the formulas look beautiful. I never understood how he got anything out of it that way, but that was what his physical intuition was based on. But mine is based on mental pictures. And so from the outset, whether I'm talking to myself or talking to a physicist colleague or talking to Lia or talking to you, I'm thinking and talking in terms of pictures. And only at the end, to verify that whether or not what I'm talking about really makes sense, only in the end do I really go through the mathematics. With Christopher Nolan working on the movie Interstellar, he would tell me something he wanted in the movie, like 7 years, like 1 day on Miller's planet, the water planet, is 7 years back on Earth. And I would tell him my intuition, my mental pictures tell me that's not possible. But then he would tell me, go do a real calculation, Kip. I've seen you be wrong before. So I went and did a real calculation, and I was wrong. If the black hole spun really fast, and I'd never done a calculation with a fast spinning black hole, then it was possible to do what he wanted. But the physical intuition was crucial to making a first guess, and has been crucial to me in all aspects of how I do science. And so I really do carry along these mental pictures. And so when I collaborate with Lia, I begin with my own mental pictures, feed them to her in terms of some very awful sketches sometimes more detailed sketches. And then she turns into something that is ever so much more beautiful. And she really makes it something that is ever so much more powerful, and that in fact will sometimes evoke some new insights that I hadn't had in my version of the pictures.
I think that's been one of the most exciting parts of this like iterative process, is that there's been, because the book was created over such a long scale of time, there were certain drawings or paintings that we both felt really positive about. And then there was either by Kip re-looking at it and then having new data, we would make new paintings.
Or computer simulations. The example was the collision and merger of two neutron stars.
I loved the original painting. Kip said, we know there's
I
new
got the
information. I was
simulations
like,
off-
no one
And the
took that painting out of the book.
the Caltech Cornell numerical relativity collaboration, the SXS team, they did a simulation that showed how it really behaves. We had it wrong.
Yeah, but there was a couple of paintings, especially of the section on singularities, where I would make them, and then even just within a short period of time of a couple weeks, Kip would relook at them and sort of, I could see that he's like learning and extracting something from the images that I made, and then he's like, oh, that's not right, it should be like this. So there, I think it's interesting that both of us are like working through our thoughts by making these iterative visual, like it's like almost like we had a conversation in images over 13 years, and that's what you have in your hands.
Kip, now with like, everybody using, different artificial intelligence platforms, especially, if you're using, hard coding everything from, Python or something like that. Can you maybe take yourself back to the early, days of coming up with let's say your pioneering days of trying to theorize gravitational waves and their possible existence, and where do you think you would be now had you had the AI tools that exist today?
I don't think it would have changed much the early development or understanding of gravitational waves. I think where it does make a big difference is in our coming to grips with complicated things at the more sophisticated stage. The computer simulations of black hole collisions, the team that does those simulations has sweat blood over it. Those simulations can be speeded up. And particularly the data analysis, searching for gravitational waves in data where you have some complicated gravitational waveform you may be searching for, that is enormously speeded up. And so I think those are the places where the AI is coming into, it's really coming into play in the data analysis, and I think to some degree in the computer simulations. But the early understanding of what is a gravitational wave, that was an issue of simply coming to grips with the mathematics and the physical interpretation of the mathematics in the period of the generation that preceded me. By the time I came along, I think we had a pretty good understanding. But the first 30 years of relativity, they did not have a terribly good understanding. And that is quite interesting that you can have Einstein's laws of general relativity, which are elegant, they're beautiful, they're conceptually simple, but getting out what it is they really say about the universe, really understanding what a black hole is, and really understanding what a gravitational wave is and how they behave, that was quite a struggle for physicists between 1915 when Einstein finished formulating his general relativity theory and the 1960s when I came on the scene.
In like manner, Lia, how do you think that AI kind of where it is now will kind of inform your work in the future, whether it's a project like this or moving forward? And we'll use kind of an example. I had the good fortune of seeing a lot of these drawings still in progress before it was published. And you can correct me if I'm wrong, but I seem to remember you had to redo a lot of the same imagery because what may look good from the artist's perspective as a finished drawing has to, at the end of the day, when you're publishing a book, has to be reproduced and look reproducible. And so there's a tension between those two processes. And so I wondered, how could the deployment of AI or any other kind of platform, nowadays kind of maybe assist you as an artist, or where do you see using it?
I see the conversation about images and AI a lot with my students who are interested in kind of exploring it as a tool. And the problem with it is that it's like an echo chamber. So, you're seeing like regurgitation of images, but in terms of my work, most of my work is very research-based practice. This is a very kind of different project than what I normally do. So I think that, at least for me, having more effective access to archives and searching is something that I would be interested in the future. But I also, it's like in the same way that you're talking about this iteration, it's like when I'm making things, I always tell my students, it's like, you can't think it and then do it. You learn it through the physical act of making, like your hand will guide you. And that is the only way that you can actually find like a breakthrough. And so I think that it may be like a better way to organize, but it would never take away what the actual artistic process is, which for all of us, like, where does creativity come from? How can we get more in touch with it? Well, I feel like AI might make us more organized to get, there, but it won't actually be the main source of creativity.
Both of you, whether it's, the written word or, image making, tend to tackle the idea of the sublime. And what role does awe and wonder play in both of your, works?
I think awe and wonder are huge inspirations. I mean, so our interaction with the universe is something that produces, at least for me, enormous awe and enormous wonder. It's an emotional thing. Paula Froley, who's a superb filmmaker, has made a film that some of you may have seen. It's basically about the roles of emotion in science. Emotion, awe, and wonder have driven me in my career in terms of trying to understand the universe. But on the other hand, if you let the awe and wonder get away from you and you don't keep yourself grounded, you can find yourself being pulled off in directions that don't correspond to what's really going on in the universe. You can misinterpret your data if you're an observer or an experimenter. If you're not hard-nosed and don't really ground yourself. And so emotion, I think I really have seen it in my career in these two ways. It's a huge motivator. Also something that gives great pleasure, but also something that can send you off in some crazy direction if you don't at certain points control yourself, and you resist having the data you're dealing with drive you in a direction that you want to go because you're not looking at the data deeply enough and critically enough.
But I have to say, how excited were you when you saw that image, the first image of a black hole? That must have been immensely
that was wonderful.
Yeah.
Was wonderful. But the other question you can ask is when we first got the first gravitational wave signal in LIGO, and that was an interesting one because different ones in this big collaboration with 1,000 people had completely different reactions. Ray Weiss and I had been working on this for half a century. And my reaction was one of simply profound satisfaction that I had pushed things in the right direction on a number of key points along the way, just profound satisfaction. Ray's was profound relief that he had convinced 1,000 young people to go into this field, and there were no gravity waves, and he was feeling guilty. He had been involved in convincing NSF and then Congress to spend $1 billion on this, and there were no gravity waves. And so it's just a profound relief for him. For the younger generation, it was euphoric. But I did find it really interesting, the difference in emotions amongst the people in the collaboration.
I would say in my own practice, this idea of the sublime or curiosity about the natural world has both driven my interest in science and even my, I feel like it's so wild to me as a contemporary artist. Like, my job is to make things with my hands and be creative. I feel like it's the biggest gift. And then I get to talk to young people about that. And I've been so deeply moved by looking at other artworks. Like today I was at the Phillips collection and walking into that Rothko room, like how you're not like, it feels like a gut punch, you know, it's amazing. And I always say to myself, like, if I can't create a sense of like shock or awe in my own studio, then I have no chance of doing that for the public or for any other person that I'm presenting. So I always I walk into my studio, and if it excites me, then I think I'm on the right direction. And actually, if it makes me like a little bit nervous, there's always got to be something that makes me like a little embarrassed or a little, you know, because that feels like I'm on the right path to something. So I would say that sense of the sublime is like the thing that I'm chasing. It is like absolutely the foundation of what I seek out when I'm looking at exhibitions and what I try to be in dialogue with, even in my own studio work. I mean, my work is, again, this is just one example of what I do, but I've made video pieces, giant cyanotypes, oil paintings, all sorts of things. And I work with a great studio team, and one of them, Adam Otke, he's been with me for like 12 years. And whenever I say, Adam, I have an idea, he always goes, okay, because I'm like, yeah, I have one project that I showed at the University of Maryland where I was learning how to fly a plane. So I was like, Adam, I want us to take 5 cameras and put them on the external points of a plane and use the plane as a drawing tool. You know, it's like those kinds of ideas are very exciting to try to create this sense of transportation. Yeah.
Do you want to add something or no? Okay.
How can I add to that?
All right, fair enough. Well, with that, I'd like to open it up to questions. We actually have 2 microphones in the aisleways, so don't be shy. Please fill the aisles. Both Kip and Lia are very, very interested in hearing what you all have to say. So please go ahead. We'll start over here on this side. Go ahead.
There, I think
There
I
we
got
go.
it.
We're here.
Okay. Thank you for being here. This is amazing. I wanted to ask. So Kip, you said that you only really wrote poetry to your wife. Is there in writing this book, were you also like referencing other poets or poems, or did it all just come from within you, or is poetry a love that you've had forever that you just enjoyed?
Well, my father had a book of great poems when I was a kid, 101 great poems published around 1912. So it was basically mostly 19th century stuff. And I really liked some of the things that were in there. But the thing I think was my favorite poem, and I've forgotten whether it was in there or I read it somewhere else, was Robert Service's The Cremation of Sam McGee. And what I liked about it was what technically people in poetry refer to as the meter. I would call it the cadence, the rhythm. So, as I say, having not written poetry really, I never made any real effort to write poetry except for crafting a few love notes to Carol Lee on occasion. I sort of started a pattern of things after Robert Service. I cared much less about rhyming, and you'll notice there's a little bit of rhyming, but not much. What I really cared about was the meter, the cadence, and a shifting cadence when there was some shift in either emotion or in direction of thought. And so I just sort of invented this for myself, a bit leaning on that. Jenny Joy LaBelle, who was a professor of English at Caltech and a dear colleague of mine, I did go to her for some help, and she gave me some books on poetry and gave me some advice, tore some of my stuff apart and helped me put, as did Diane Ackerman, who's a dear friend of both of us at Cornell. And I got feedback from several different people, but largely it's just sort of self-grown verse based on my enormous enjoyment of the creation of Sam McGee.
Sounds like you are actually an artist as well as a scientist, and Lia, you are a scientist as well as an artist. This is wonderful. Thank you so much.
Thank you for your question. Go ahead.
I thank you very much for your presentation. And so I guess one thing as a scientist, I think we all look for that order in chaos, but we realize that we're starting to play with chaos at the beginning. And I guess in both of your walks, yours as a scientist becoming an artist and yours as an artist becoming a scientist, is that where you found your joy? Because I think that's really important for us to get out there. You know, it's just as important what brought us to do what we do as much as what we do. So is in your individual walks, would you say that that is a very important starting point, I guess?
Like for me, so much of the joy of this book was walking into the unknown. As an artist that works with galleries and museums, and probably as a scientist, there's certain kind of rules that you have to like stay within your swim lane, within your discipline. But if you're making something new, then there are kind of no rules. And like I said, I know it seems strange with this book here, but it kind of like for many years, we didn't really know what we had. We had an ongoing joke that made us giggle for 10 years where we said, no one will want this book except for the two, we'll sell 4 copies to Kip, to me, and then our wives will have to buy it because it's gonna make them look bad if they don't. So 4 copies, we'll sell 4 copies because it was really, it was like, we made the book that we wanted that didn't exist, that if I was to read a book about black holes, this is how I'd want to read it. So I feel like the joy was in that unknown discovery. It's like this kind of feeling like you're making something that never existed before.
I have found over my career that I can get joy, I can get enjoyment in almost any direction I look. I functioned as an engineer. I designed solid propellant rocket engines when I was young for Thiokol Chemical Corporation. I've functioned as a geophysicist and trying to understand geophysical structures and seismic noise at the South Pole when I was trying to design an experiment to be done there. After being a conventional professor at Caltech for 50 years, I just decided I wanted to do something else for my next 50 years, just move in some other direction that was completely different, or not entirely different, because I chose directions where I could continue to involve the science I had done on the warp side of the universe, but new directions with collaborations with people like Lia and with Hans Zimmer on multimedia concerts and with Christopher Nolan. And I'm just, whatever direction I go, somehow I'm able to find fun and joy. The ones I've chosen have just been fabulous. And if I'd chosen something else, I don't know whether it would have lived up to this. But it really is true that any direction I look, there are really interesting things to explore.
I constantly remind him he's doing a terrible job at retirement.
Next question.
I'm Michael Nelson, Caltech undergraduate, 1981. So I grew up in the 60s and early 70s, the space age. I watched the Jetsons. I mean, science was all around me and it was positive and exciting. I'm on the board of the Arthur C. Clarke Foundation, and he was part of my childhood as well. 2001, A Space Odyssey. We're having a very hard time celebrating science now. And our foundation is having a hard time getting support for celebrating the future. Everybody's so concerned about now. What you've done here to celebrate cosmology is very important, but I think we need a bigger, broader cultural change if we're ever going to get back to the world we had in the 60s and 70s, when there was almost no resistance to funding new exciting things and going to the moon and doing the things that have opened up genetic engineering. Do you have any crazy, wild, out of the box, out of the universe ideas
Let me just
getting
say
us
that
to
I
approach
think these
science
things,
differently?
I think these things come in waves. When
4-year waves.
when I became convinced that there was a real possibility to discover gravitational waves, that was a time when you could not get NSF or MIT to buy into this at all. It was, things were a little more rigid. Caltech was a unique institution. We could manage to do so. But then things opened up, and there was in the 1980s, there was much more openness and enthusiasm about taking risks. And it was beginning to happen in the 70s, and it was not there in the 60s and the 50s. We then went through a period in the, at least in areas that I was connected with, in the 80s and at least the early 90s, when society and Congress were very open to risky, wonderful ventures, and that's changed, and it will change again, but we have to work to help it change again.
I mean, I see this as a problem in the arts as well. And I have 2 small kids, Jasper and Atlas, 3 and 7. And I took a very high profile speaking gig at Eagle Rock Montessori. And I sat down. I mean, this is cool, everyone, and I sat down and I said, how many in the room are artists? And of course they all, they're 4 years old, they all raised their hand. And then I said, like, how many of you are excited about nature? And they all raised their hands, because there's something about, like, when you're young, you feel like you are a scientist, you are an artist, you feel confident in both of those endeavors because you're curious about the natural world. And then there's something that happens. And what is it? Is it like 6th grade, high school, that all of a sudden we feel like we have not been invited? And I think that this was one of the goals for our book. It's one of my goals as an artist, especially existing within the art world, which is a world that I love, but I also feel critical over, of being very exclusionary in certain aspects, where you want to try to widen that world. So what is it about that at a certain point in science, people feel like, oh, I'm not smart enough to know that. And I always, like, in my like, I'm doing a presentation about my bigger art practice, I always say, like, if I took you to watch a sunset and I said, you won't understand this, you would very, very naturally be like, what are you talking about? You would feel like that's not true. But when you talk about black holes, I'm like, I try to remind everyone, black holes are part of nature. Like, you should feel like it can be part of you, and you have access, and you can be as curious and invited. Is it that you need to understand really complicated mathematics? Maybe not. You can maybe understand it in a different way. So I also wonder if there's a way for both art and science to have a more mindful way to be, have a wider invitation at a younger age.
I see there are 2 more people, and we'll limit the questions, and then afterwards, actually, Kip and Lia will be in the gallery, where there's a wonderful exhibition and presentation of her work. So if you have additional questions, you can ask them there. So go ahead.
Very much for presenting your artwork. I have a small question on, like, sort of the nature of your art. Is there, like, a particular reason you chose to depict, like, the black holes as not particularly scary or not particularly destructive? I mean, I haven't read your book, but, like, from, like, the slides up there, it, like, benign or something, or beautiful.
Let me just say, her wife goes through hell in this book. twisted, she's stretched, she's torn apart. And
It's funny, my wife Felicia, of course, knew that I was working on this book for 13 years, but I never showed her a draft. And then before the book was published, we did this like very small presentation at Caltech. It was like 8:30 in the morning for like 40 people. It was like the first time Felicia actually saw what we had been working on for 13 years. And we walked out and she goes, Jasper our daughter is going to be so pissed at you because she's like realized what happened. But the choice to include Felicia, and I think what you're saying, that there is a real, there's a huge effort on my part to actually seduce you by beauty, seduce you in a way that makes you kind of wonder what these objects are and present them in a beautiful way. And the inclusion of Felicia is to make you kind of embody that versus like astronaut A, right? It's like it's easy for you to have that at arm's distance, but to try to have it very intimate. And you'll see in the book, Kip just doesn't write like there is a character, Felicia. He's literally writing like I'm in the book, passing a book through a wormhole to Felicia, and he's writing like Lia and Felicia. It's.
But I think a key thing is that you read it, you see Felicia undergoing these various contortions. That describe accurately the kinds of forces that exist around a black hole, but you recognize as you see it that this is allegorical in some sense. I think you don't really feel the violence but you understand the physics of what's going on in a personal way. But well.
Yeah, I think it was really important that we included the body. Mm-hmm.
Last question, go ahead.
Thank you. Thank you so much for this presentation. This has been very inspiring. I have the privilege or luck of being a solar physicist, and so I get to work with an object of great beauty every day. But as a scientist, also, I have a very good colleague who believes that every good scientific point that you want to make should be able to be reduced to a line plot. And that brings, what we don't get trained as during graduate school is in data presentation or concept presentation in terms of, how to make a figure that conveys the information in a clear but yet elegant manner. And yet we are faced with real challenges of expressing and exciting our grand community, the country, the world about science, and I think art can be a very good conveyor of that. Comment a little bit about, or think about, or brainstorm a bit about how can we bring graphic arts, art presentation into the sciences in a more established way, so that it's not a one beautiful book, but we can help with the education and our communication of our science as beauty to the rest of the world?
Let me just comment that my PhD advisor was John Archibald Wheeler at Princeton. And he taught me and his students the power of drawings that are more than just a line drawings that are evocative, drawings that are designed to capture the science of what's going on, but also to do it in a manner that can evoke emotion as well. He was just an inspiration for me in this kind of a direction. That's one remark. A second remark is that when I was a freshman at Caltech in 1958, I was at the very end of a long Caltech tradition where every freshman had to take a course in engineering drawing. And so I took this course, and in fact, it was one of the most valuable courses I ever took, because it taught me perspective. It showed me how to make drawings that really had a three-dimensional feel. And I then used that through my whole career, right from freshman year onward. And so there were those elements, at least in my training, that have an awful lot to do with where I am today. and with the ease with which I have collaborated with Lia.
I think another way to think of this is that a real collaboration is not just one discipline serving the other, right? Like Kip's example of taking a drafting class. It's not that, and you can tell, it's not that Kip had, a text and he said, Lia, illustrate this, right? Like this is a totally kind of unique collaboration. And I think when the disciplines, visual and science, like realize that one can elevate each other, and it's not just that like you're looking for a collaborator who will then be in service of your solar science, but that it might do something to inspire you or let you see something in a different way. I think like one of my favorite lines that Kip wrote is the slide that he read. He is a beast who's also materially composed. Like we can't get away that we're just visual beasts, I mean, we are always inundated with visualizations, inspired, repulsed, and so these kinds of things I think thinking of visualization of science as an afterthought, that to me is like problematic of finding ways like from the get-go. And I'll just give one last example is I teach a course called the Intersection of Art and Science, and I partner with NASA's Jet Propulsion Lab, and I bring my students to JPL like every other Friday. And in the first, they're just like, whoa, NASA is cool, but what am I doing here? I'm not smart enough. I'm not good enough. There's nothing I can contribute. And by the end of the semester, they realize that like you have a young sculptor who's trying to make something that never existed. They just heard from the engineer who put a mechanical probe on the surface of a moon that no one has ever been to. And that kind of problem solving, yes, there is a gap, but you actually kind of going back to Taras's introductory remarks that like the more we actually reflect on how much problem solving and intuition and creativity and excitement that we have from the beginning, that I think will then show the right directions for that kind of collaboration, which I completely agree is like absolutely essential to communicate, the excitement of what is happening in science.
Let me just add one more remark about this question. Roger Penrose, one of the really great physicists of my generation, does superb drawings, three-dimensional drawings that are both artistic and extremely powerful, extremely intricate in conveying what is going on in whatever it is he's dealing with. And if you take students who have never been really exposed to powerful artistic scientific drawing, just send them to look at Roger Penrose's drawings. And they're so inspirational. They have been to me through my career. That I think anybody who really looks at them and thinks about them will recognize how much power these visualizations can have in science.
Well, the book is called The Warp Side of Our Universe. You can pick it up online and find bookstores near you. I want to once again thank Kip Thorne and Lia Halloran for taking the time to present, take questions.
Thank you.
Thank you.
Thank you. That was great.
Yep. You're going to talk with me.